Thanks for coming out, and hope you enjoy this session. I'm Mark Pollack. I, along with Mark Fisher, lead the Spring XD project. And today I'm going to give an update of what we've done basically in the past year, and future stuff, which is why there's the boilerplate. So the two main themes are how popular projects in the big data ecosystem, how we're using them and integrating them into Spring XD. And then going to show a preview, I guess. We explain more in Mark Fisher's talk about what we're doing for the next version of Spring XD. So really these two sort of areas, big data and cloud native, is important because the next version of XD is going to really leverage a lot of the cloud native architectural principles, and you'll see that when we get to it. So it's been a really busy year. It's quite shocking when I put this slide together. We released pretty much right before Spring 1 last year, our 1.0 GA, and that had the foundation of pretty much everything that you're used to seeing. It had the shell, it had the DSL, you can do batch processing and stream processing. We had the analytics, those kind of counters, sort of NoSQL analytics, I like to call it. Also had support for machine learning through PMML files that can be imported and evaluated. And the runtime that we developed was standalone, a fault-tolerant standalone runtime, and one that ran on Yarn. But essentially the runtime was Zookeeper-based. And then 1.1, the big feature we did is add support for Kafka. There's a talk by Marius that you should attend if you want, and also one by Joe Stein on Kafka. It's a lot of work went into the Spring integration Kafka project to really make it a better programming experience, similar to how you might use Rabbit message listener containers. You can use Kafka message listener containers. So I'm not going to focus on that, but quite a lot of work to bring it into XD was done kind of down the stack. Then we had support for Reactor and RxJava. That was hinted at in the keynote yesterday by Jürgen. This is an important paradigm going forward to have reactive applications. And from my point of view, at least, in terms of where we use it in XD, it's nice because it has a functional composition style API and can do things like time windowing that make it fairly attractive. And not everything is done in Java, as you know, in the big data world. Stuff is done in R, a lot of stuff is done in Python, so we added native support for Python. Scoop integration is another ecosystem project. We added authorization. Then 1.2, earlier this year in the summer, we added UI for authoring streams, so a big improvement to the UI. That's called Flow. A lot of performance improvements. We really benchmarked very heavily on Rackspace, our Kafka performance to get numbers in the millions of messages per second. Automated deployment through Ambari. So if you want to use Ambari as your means to deploy your Hadoop cluster, you can then now also deploy XD onto Yarn with Ambari. And the last thing is Pivotal has a product called Hawk. It's a SQL on Hadoop solution. And also there's a Greenplum database, which is its predecessor in a way, historically, from the lineage of the products. And we provided a sink so you can ingest data directly into Hawk, the SQL on Hadoop product. So I'm going to go through a whole bunch of these. I got a lot of demos, but I guess I got a lot of time. So pretty much all of these I'm going to cover in some way. So the first one is Flow. So the author right there, one of the main authors, Andy. It's a HTML5 canvas application. It's inside the, you access it inside the XD admin console. You can drag and drop, like you've probably seen with other sort of integration products, sources and sinks from the left-hand side, put it on the palette. You get health monitoring of your stream, visualization of metrics, and also it's expanding out so that you can use it, for example, with Spring integration, but not have it in the XD. So it's in the process of sort of spreading out to other parts of the Spring ecosystem. And so what I'd like to do is start showing you that. Let me just bring this guy up. close that. Really? That's crazy. There's no little minimize button? Huh. Let's keep that there then. So what I have here running is basically XD distributed setup. There's Zookeeper, there's Kafka, I have Redis, database which I'm not really using, it has to be there. The admin node and 2 containers and a little UI for Kafka we'll look at later. And let's see how you can do this in this resolution. If you go to the Streams tab, there's nothing, there's no containers right now. Go to the Streams tab. Whoops. Yeah, let's see, maybe I can shrink it. Ooh, yeah. So up here is where you can type in, and you can actually get some code completion as well. But you can search, for example, for the modules that match the name. So here I want to do Twitter search. I just drag it on. And now I'd like to, for example, do a query. I can do control space, and it will auto-complete that. And for fun, did this a long time ago, I think in 2012. You're going to find out who's more popular of the candidates for the election and compare it with pop culture. In this case, there's the MTV Music Awards going on in Europe, and Little Mix apparently is pretty popular. So you can do that. And then you could also tap this guy and just put this to a counter. Name mix, oops. And we'll call this mix stream. I'll call this mix stream. So now I can hit create, and I'll call this mix tap. And I won't deploy it yet, but I'm just going to create it. So now if I go back to the definitions, you see I have the stream and the tap both defined. And so I can go here and oops, stream. Oops. How did that work? Drop it on that. And this goes to a counter. Style counter. Let's do this. Create the stream. Tap. Create those two. Oops. Oh, that was why. Thank you. See? Another feature I'm sure Andy's quite proud of is it makes a little X, but it doesn't make you. So this is so good to actually intuit that you're using the wrong source. Anyway, let's create that. Donald tap. And the last one. There we go. And this one is Hillary 2016. Oh, that's a counter. All right, so I can can go back here and look at all the definitions. And you see under each, you can get a little visualization of what they're doing, and when we deploy them, you'll see they'll go live. So let me deploy the taps first. There's no properties for this one. Okay. And then go to the next tap. Deploy. And so now if I go to this tab, it's green. The little dot here indicates there's one instance running, and if you hover over it, you can get some additional information, including rate information, which I forgot to turn on, but that's available too. So now I'll try to, let's give the poor candidates a head start against pop culture and deploy this first. All right, Donald. Do that. And then do that. Hopefully they're working. Yep. So, yep, that's fine. And now if we go to here, you can see that there's well, you can just click on counters, gauge, rich gauges, or you have this drop down. I could do the drop down, I guess. Here, counter. Ooh, why are there so many? Let's just go here. I think I have extra ones somehow stored. Now, those are the 3 live ones. I think I had the others from previous tests. So you can see now you can kind of very quickly get a visualization of what's going on. And there are, of course, other dashboards out there in the marketplace. Like I think the Zeppelin is one. And so this is really using the REST API. And so I think it's a nice avenue for like further investigation next year to hook in other dashboards as well. So who's winning here? Let's see. Hillary's winning. Holy cow. It's the first time ever. So yeah. So that's the basic the UI with the flow admin and the oops. Let's go here. Change. Might as well destroy everything. Oops. Just to clean up. Okay. All right. Let me just hop back over to the presentation.
So have you stopped using the CLI now?
No, not really. I mean, I think the fact that this has code completion, inside the upper tab, means you can kind of be productive in the same way. But out of habit, I just kind of use the shell. But some people, the reason we did it is we had a lot of requests for it, right? So there are people who really enjoy doing it this way. So the last next bit is about Python, the Python integration that we have. So XD 1.0 provided the evaluation of models based on this predictive model markup language specification. It's an XML specification. A lot of data science packages like R and mathlib and what's the other one? Kit. They allow you to export the model that you've created in this format, and then you can evaluate it. And we are evaluating it using this project that's called the Java Evaluator Project, JPPML Evaluator. That's the GitHub repo. But a lot of people don't want to use that. They want to use pure Python or the native thing that they've done because they have so many great things natively that might even be beyond what you export in PMML. And so we added in 1.1 a way to add Python into stream definitions. So you can really have a bit of Python code that executes. So let me just pop over there here now. Go to my cheat sheet here. So There's a little bit of glue code we provide, sort of a XD stream interface, so that you can start to execute the code. In this case, it's this classic data set about flowers, iris flowers. You can predict their species based on the width and the length of their flowers, the sepal and the petals. So here we load the data set. These are the species, those three that we get out. And basically we created a model, and then you ask, this is the major function that gets called processor. Whoops. And you're going to take out these elements in the stream. Basically, we'll post text. Then out is going to come the prediction. Let me just move back to this. I'll just create a shell somewhere. Let me create a new window. So I'm going to have an HTTP source. Let me move this up, probably. Then I'm going to call out, actually, it's really a shell processor. And so it so happens that the shell is running Python, and we have a little extra library to give you the information so you don't have to parse literally the standard in and standard out, which is how we communicate with the shell process. Then we're just piping into a field counter. And the field name we're looking for is predicted species, and that's the name of the counter. Just deploy that. And now, oops, just going to post this one here. So I'm posting a JSON payload with sepal length, sepal width, petal length, petal width. And then if I do counters list, and then counter display. Oh, sorry, I didn't create the. Yeah, it should be. Oh, I have to actually. Yeah, where is it? That's weird. Oh, field value counter. There we go. Oh, I had it before. I didn't clear out these counters from earlier. So let me do the post again and see one of them go up. I'll do it twice. Yeah. There you go, that's 6. And if I do Virginica, that's this guy. Yeah, went up 1. And so on. So that's pretty cool. I think you can now, natively use Python, or really any other shell, but Python is a little bit better supported in terms of what we do. Okay, so let me go back. On this slide. So how many people here are familiar with Apache Kafka? Show of hands. Wow, pretty decent amount. Well, that popularity reflects why we spent so much time working with it. So it's build, the first line there comes from their website as a publish, subscribe messaging middleware, and then the little twist is rethought as a distributed commit log, and that really reflects the internals of how it stores the data and how it really efficiently operates. And really, it's popular because it's fast. In our performance tests, if we were on a 1 gigabit network, we could easily saturate it, pretty much with just one process in a 100 or 200 byte payload, just moving data from point A to point B. Eventually, we tested on a 10 gigabit network, and so we were able to scale up. That's important. You can store tons of data. It was meant literally to store terabytes of data if you so see fit. And it stores it, and in addition to delivering it to consumers, you can ask for it to sort of replay from some position in the log. So basically as an index, and you can replay from any particular part. It's clustered, and it's highly available, and so it also uses Zookeeper as a means to determine its coordination for state in the cluster. And also what's very important is it has the concept of partitioning. Topic, just like in JMS, is the essential unit that you do publish and subscribe over as the common shared name. But inside the topic, you can have partitions. So you can divide up the data into multiple partitions, and you get to decide how you'd like to divvy it up. So for example, you could divvy it up on some business key like customer ID, or be as coarse or as fine-grained as you like. Then you can have consumers that listen to just that partition. This allows you to sort of effectively route traffic and keep local state, and I'll show this in a moment, because you know that you're always going to get, for example, in the case I'll be showing, sensor IDs that are always even versus sensor IDs that are odd, or you can imagine other cases. So that's in short what makes it very popular. Here's a sort of somewhat complex diagram, but basically you have a producer and a consumer. You can have many of these brokers, so you can deploy as many as you want. They make backup copies of the data as well. And this P0, P1, and P2, those are the partitions. There are 3 partitions, and those are sort of the main ones, and that's why they're in bold. And the R is a copy of that partition on a different machine, the data. And Zookeeper is used to consume and manage all that state. So let me just go show a demo on that. I got that going. I got that going already. So here I'm just going to create HTTP log and deploy 2 of the log modules. And what I'm doing here is I'm saying when it's going from the HTTP source to the log sink, that pipe is really, it's a topic, right? And I get to now decide what the partition key, namely what in the data is going to use to determine whether it goes to one partition or another. So if I do this deploy, and then go to this little UI thingy that I found, let's see. So you can see these are all the topics from my previous demo in the taps. But the one that we created right now is this one, demo 2, if I remember correctly. Yeah, demo 2. Oops. And you can see, unlike the other ones, it has 2 partitions, right? And you really can't see too much here. But anyway, there's 1 and 2. And partitions are owned by certain nodes in the cluster. In this case, it's always the same one because I only have one Kafka broker running. And so you can take a look inside. This is kind of cute. So if I, oops, all right. Oh, what did I do wrong? Oh. So what this is doing is generating, I'll stop it, sensor ID and temperature pairs in JSON. And basically, for sensor ID 7, the values that's going to be around 11-ish or so. For the next one, 8, it's going to be a little bit higher. For 9, it's going to be a little bit higher. So they all have kind of a median point. Higher the sensor number, the sensor ID, the higher the temperature. And that, so if I just let that run for a little bit, if I create these 2 streams now, actually, I can use, oops. Oops. There we go. Go back here. So I'm actually just to show you the data that's inside the partition. There isn't, unfortunately, a cute command line way to do this with Kafka Broker itself. I'm going to look at the topic demo 2 .0 and the partition 0. The .0 is a convention we have in XD of how you name each hop, basically, each pipe. You start, the first pipe gets a suffix of 0, stream name dot, pipe number, basically. So if I go to one of the logs, let's find where they are. Did something bad happen? It's being closed. Oh, that's not. Huh. Demo 2. Partition 0. Oh, let me, no. Let's get rid of that. All right, let's try it again. Okay. Why is it not showing me? I don't know what I'm doing wrong. Sorry, guys. That's not good. Oh, connection refused. Um, that should be fine. Oh, the HTTP thing failed. I probably have a conflict on a port or something.
Network okay?
Huh?
Network okay?
Yeah, it's not the network. It's all local.
Check.
I have something on 80, probably something on 8080, I guess. Let's see if there's something running here on 8080. No? I'll try one more time. All right. I guess that's okay. All right. There we go here. Oops. Fine. There we go. So basically, this one is all the odd ones, you see. 5, 7, oh, why? 6, oh. This, it's not working. Why is 6 there? Oh, I have another, I think I demo 2. What did I do wrong? Oh, I think they're deployed on the same container. That's why, unfortunately, they went to the same one. So here we go. And then do this. Oh, sorry, I think I'm gonna have to bail. We need to deploy. No. Yeah, unfortunately, they're in the same one. So basically, all the stuff, if you just look for Kafka P0, that's the contents there, so that's odd. You know, look at the logging for the Should maybe make it go to a file or something. That might be better. So you look at Kafka P here. This one, there's a 3. Kafka P1 here, it's a 1. So that's all the oddballs. And if you go here, oops, not there. And then hopefully went to the other. They're all in the same container. Anyway, I think it's too complicated. I'm sorry, the demo didn't go as planned. They kind of all deployed to the same spot, so it's a little difficult. Here you can see the. So anyway, I'll just move on. The point is, odds are actually really in 0. Partition evens are in 1. There really should be an easier way to show that. So my bad. So now what I wanted to do really next is really just a precursor to doing some stateful computation on all the evens or on all the odds. And the way we'll show this is with a functional style API that we'll show it with RxJava. RxJava's history comes from the ReactiveX project. It actually originated from Microsoft. And it's built as an asynchronous API where you use observable streams. And there's ReactiveX is sort of the umbrella project because there are many language bindings. The one for Java is called RxJava, and it's mostly developed by Netflix. And from, there's a lot to it, just giving a quick tour of a variety of technologies. But the nice thing really is you can, if you like this functional style API, you can write, from, this collection of names and do a map, and you can kind of get more and more sophisticated in what you do. And so as an example of this, you look at, oops, why did I do that? That's fine. Going to deploy a, let's see. Have to reopen. So here's an example. We're going to compute the average of the sensor's temperature. And what you can do is you could create a window. So you can do window averages. Then I'm going to get the sensor ID. And here I'm going to compute the double. So this average double is a utility method that exists in the library. And then once I'm done with that, I'm going to spit out the sensor ID has an average temperature of foo over this time window. And so that's a stateful calculation. You wouldn't want to have different sensor IDs going to 2 different places, because the next step in this stream that I'm going to create is showing the top sensor values. And here's the code where it does that. So basically, I'm going to look for the top, pass into it an integer, which is what are the hottest sensors, basically. And then this is getting all of them. So there's going to be a partition to go to basically 2 processors, each getting their part of the partition, and then going to sort of reduce or merge back again to compute basically which one's the hottest. And hopefully this works. Let's close that. So those were custom modules. So basically, HTTP, average temperature, top sensors, right? Those are the 3 things. And I'm going to show the top 3. And here the deployment ID is what's important. So I'm going to deploy 2 of these average temperatures, so they each get half of the data consistently, and I'm going to partition based on the sensor ID. All right, so it's deployed. Go back and then generate some data. And if we look here, you'll see that 7, 8, 9, we could squeeze it out a little bit more, are the hottest ones, always because the data was generated at the higher the sensor number, the higher the temperature. So this is an example of sort of more sophisticated partition data processing that you can do. And if you're careful, obviously, in how many partitions you can create this kind of powerful stream processing. And Marius will be giving a much more interesting talk. Maybe he'll be slicker with the demo than I am to show you how you do this in more use cases and also do things like stream merging. So let me stop that. Stream. And now, yeah, it's back to doing nothing because the stream is dead. And let me kill that. All right. Let's go back to here. So the next topic, again, there's a whole session you could do on Spark, and there is going to be a session on Spark that will talk about Spark just as it is, and also then the integration in much more depth. It basically is a large-scale data processing system. How many people here have heard of Spark? Yeah, everyone, right? Super popular. The key concept they have is an RDD, a resilient distributed data set. It's immutable. Basically, you load data into the cluster. It lives in memory. And then you do computation on it. And there's a way to do directed acyclic graph, they would call it, of these data sets. And the sort of magic is that you write in a very high-level functional style API, similar to what I showed you in RxJava. And this can do batch processing. So sort of very popular because it reflects, I guess, in a way, the evolution of just technology. When Hadoop was created, it was all about disk locality. You had to send the computation to the disk. Now that's seeming a little bit less important, but also it's too slow for many people, especially if they want to do a lot of iterative work. And so the idea is that you load it into memory, and you can work on it in memory. It's much faster. And so they have both batch, that's kind of its main use case, but they also have a stream processing framework where you basically do micro batches, they call it. So they take little windows of time, in this case, just using numbers, 0 to 1, 1 to 2, 1 to 3, and that basically is how the event stream is broken up. And then when you ask to compute, let's say, an average, it is continually running over all these sort of chained RDDs. It's a fairly involved system, I guess you might say, and how it works under the covers. This tries to show a little bit of how it works, or where our role is in it. Suppose we had HTTP pipe HDFS, and traffic is coming in. These 3 different colors indicate, again, these different types of partitioning, right? That I want to send the blue data to the blue processor, the green to the green, the red to the red. What we do is basically, Spark typically has receivers and senders. Those are sort of the equivalent of sources and sinks in our terminology. But the way we integrate with it is that you don't have to use their sources or their sinks. You can use any of the sources and sinks that we have in XD, and we'll just inject the one processor logic, this thing in the middle there, this executor, basically. So you just write the code, which sort of looks a little bit like this. This is the Scala version, where you're doing word count, and you just flat map, basically. This is showing their API, the words, and then you map them, and then you reduce by key. But this is all happening distributed against these in-memory data structures. And so there's a very, very quick demo on that. Let me just go to it. I have to kill this because I did not want to go through the pain of setting up a real cluster. So I'm going to run, let's see, single node. And here I went to the Gutenberg project and downloaded his Beyond Good and Evil book. So I have some data to work with. So this guy is up, I guess. Yep, there's nothing there. And so I uploaded a small module that has that word count. I should probably just try to show you that. So this is just that code that I was showing you earlier, but in Java, not in Scala. But if you write it in Java 8, it looks very similar because you can use lambdas. And so if I go here and just, oops. Go and paste this guy. So getting the file, then doing it to word count, and doing it to the log. I'll go to wherever I ran this. There we go. It spits out all the word counts. So not in capital. Schopenhauer, fancy. So that's showing how it works. It's using an embedded cluster because I didn't want to set up an entire Spark cluster, but it's the basic idea. So you should definitely check out the talk that's going to happen. I think it's tomorrow on that. Oops. So what's next? Basically, we had XD 1.2, and now our next generation isn't called XD anymore. We're calling it Dataflow. And the reason, or Spring Cloud Dataflow, actually. And we have a milestone release. We released it just before the conference. You can go to the project site and download it. And the essential idea is that we've kept a lot of the higher level APIs, so the REST API of the DSLLS the same, but underneath we've sort of massively re-architected it to overcome basic sort of limitations that we found in the architecture of the XD1 series. So sort of one of the first pain points we had, people maybe in the room have come across this, is around we have a class loader scheme, much like in a servlet container with a parent and a child, but we sort of eventually ended up with having so much in xdlib home directory that sometimes modules, when they loaded, wouldn't see the class correctly because like part of batch was loaded by the parent, but the child also needed to see it, and so we had all these problems because we kind of overloaded the root of xdlib too much. A lot of requests to have streams that have the pipes, but are actually not going over the network at all, right? And that was sort of a limitation. But the real kicker for us to change the whole architecture was when we got finally to all these additional requirements. Like, okay, it's great now that I have the stream deployed, but aside from how do I scale it up? And how do I scale it down? How do I upgrade a version of a module? How do I fall back to another version of a module? A little typo there, allocation. We had requests for certain modules to use more memory than other modules. And so, unless you started up the XD container with that memory profile, there was no way to really do that. And so this would have required basically us, the XD team, to start adding all these features. And there are a lot of other people out there who are working on this problem, right? Namely, how do I launch an app? How do I scale it up? How do I scale it down? Obviously, Cloud Foundry is one of them, but there are many others, right? There's Fleet, I think, from CoreOS. There's a Docker Swarm. There's Kubernetes. There's a whole sort of ecosystem developing around these orchestration tools for distributed applications. And so the decision was that we'd make a SPI interface and sort of delegate all the stuff that we were doing in our runtime, just throw it away and delegate it to other systems to handle. So this way, we don't have to reinvent the wheel, and we can plug into the framework that you like best. But our opinion, in terms of what we support first, is supporting Lattice. And so I don't know if people went to Matt Stein's talk on Lattice, but it's essentially the components of Cloud Foundry, but packaged up in a way that's sort of easier to deploy. And so it's sort of more lightweight. You don't have to use Bosch, for example. But the components inside of it, the Garden container, the Go router, all of this is there for you. And so that's sort of our runtime. There's still Yarn. And to get rid of this class loader problem, really just to sort of go in this sort of cloud-native style, I think modules really become microservice apps. So now every module is a runnable boot app. And the runtime, instead of having our own Zookeeper-based runtime, we have an interface where we just delegate out to Lattice or Cloud Foundry or Yarn. We have a local implementation, which is kind of like single node, where it just spawns basically an application context, the boot app, sorry, in the same process. So that really wouldn't be recommended for production.
So why did you drop the mapping the serial SPI to the traditional approach, which you have multiple container process stuff?
So, yeah, so the question is, why did we drop it? The reason is that we had these additional requirements that we would have had to add into our runtime to meet. And so you start to look and say, is anyone else doing this, right? We're working at a company that's making one of these things, right? And so we didn't want to reinvent the wheel or do duplicate work.
Yeah, but that's still the most likely way to do distribution, because even with the Lattice, you still have some,
Yeah, so there is a price to pay for this, right? It's not, so for example, there's a product out there from Spotify called Helios, right? It's a Zookeeper-based runtime that spins up Docker images using a Docker API. So all you need is Zookeeper and Docker basically everywhere, and they have this job spawner, right? That's like slightly lighter, but still, that's maybe the most equivalent of the ones I've seen that are out there that we could map onto. But there's sort of no free lunch, right? The minute you get to saying, I want to support rolling upgrades, I want to have resource allocation on a per module level, those requirements you can't really meet in the traditional way.
But the modules in XD, at least as it's spelled out in version 1, was supposed to be much more lightweight because they were just a Spring container. It's kind of a different ballgame from software container, right? Like Docker is. Right?
Yeah, so the Docker, so the question is like, weren't the modules more lightweight, right? Before versus now. So yeah, the jar file was smaller. I think, let me get to this slide here. It's the exact analogy of what's happening with web apps and servlet containers. You can argue that my web app, right, my WAR file is small because all the dependencies are in the servlet container, all those shared things, so it's small. But people have moved away, right, and they're now using boot with an embedded Tomcat server, so the jar is now bigger, right, but the benefits you get for sort of deploying it in this sort of cloud-native way outweigh the extra size of having an executable jar. And so, the next level up is you can say, not only do I have an executable jar, but I have an executable container. And you can decide if you want to deploy containers or you just want to deploy apps. In Lattice, you can still deploy just an app, and all that stuff is just the runtime behind you. So I don't know if that clarifies it or not.
Well, people are already starting to get used to the XD style, right?
Yeah, it's a big change. I mean, it's going to be a change, there's no doubt about it, but we think it's far better. I mean, personally, for us, the team, we've been working on this change for the past 2-3 months. It definitely feels a lot better in many ways. So I think we're all pretty happy about it. And, this is, of course, probably one of the best opportunities, especially after the talk probably, to really have a lot more discussion, to see, what you like, what you don't like. Are we really crazy? I mean, I don't think so yet. We haven't gotten such bad feedback. But we want the feedback, right? And we want to know like what SPIs you like, which ones we should support.
So we'll
Yeah.
questions later.
Let me see how much time I have left. Oh, 40 minutes. We got a lot of time.
So how would you best develop this with a local Lattice install and deploy?
So you can, yeah. So the lightest thing you can do is have local node. Sort of the single node equivalent, that would be the lightest thing. The next thing is you get Vagrant and VirtualBox or VMware on your machine. And the way Lattice ships with a vagrant file that you say vagrant up. It gives you a little URL, and then you point the admin console to that, and you're up and running. And that's what I'll show. I'll show that here. So this, is showing sort of how we're starting to re-implement XD. And there's a project called Spring Cloud Stream. So instead of having modules inside the XD container and Zookeeper coordinating all of it, instead we have also a new programming model that goes along with this, which hopefully people will find to be better. The modules are standalone executable boot apps, and they delegate to an SPI. And if you wanted to, you don't even have to use Spring Cloud Dataflow, the thing that launches all of these apps for you. I'll show you that you can just run these apps, and if you set the properties correctly, they point to each other over the message bus. So in that sense, it's sort of even more lightweight, right? Because you don't even have to have any container. You just have these apps, you set some properties, and they run. If you wanted to have it deployed inside of Lattice or inside of Yarn, it's still supported, but you don't have to set all those properties by hand. And obviously, when you get to things like partitioning and multiple module counts and lots of streams, you need something to kind of coordinate setting all these properties. But for simple cases, which I'll show, oops, sorry, you don't really need to even bring in any heavyweight machinery to get these components running. So here again is sort of a left-right kind of thing. So before we had XD, we had the admin, had the modules, had the containers, and now this has been broken out into many projects. It actually helps us internally, really, in terms of how we develop things quickly, because we've kind of broken up this larger project into many small ones. So Spring Cloud Stream, essentially you can think of Spring Cloud Stream as boot auto-configuration goodness for your Spring integration apps. So it knows that you should have an inbound channel adapter and an outbound channel adapter. So it can create these things for you automatically through auto-configuration. Same thing for batch. That's what Spring Cloud Task is. Through auto-configuration, it create the job repository and all that other infrastructure. So you can think of that lowest level as boot for SI and boot for batch. All the modules that we shipped, we now have as executable jars that live inside. Another difference is they live inside a Maven repository. So instead of having a local lib directory, all the artifacts are hosted in the standard Maven repository. And then on top of all this is the same REST API, the same shell, the same UI, and we developed the SPI for single node, Lattice, Yarn, and Cloud Foundry. So I'm going to show just a very sort of short demo of this, but Mark Fisher and Dave Sire and Patrick Peralta, there's 2 talks amongst the 3 of them. I think Mark must be doing double duty. And they're going to go into it in far, far more detail. So this is just sort of a teaser, I guess you say, introduction to it. This is just showing a little bit more the pieces, right? The shell, the UI, they'll all go to the admin. But now the admin's sort of much thinner because it doesn't have any responsibilities around the runtime for coordinating it. So it's mostly delegating the orchestration task to this module deployer component. And the components of the admin that are really important to us now are, of course, the DSL parser. The stream repository is basically where the standard Maven repo, same thing for task, and then we register them locally in the module registry. Okay.
The model deployers together with it's a single process that Spider shows.
The module player is a class that has multiple implementations.
It's a single process.
Yeah, that's a single process. So that, yeah, everything was there was a single process. I mean, well, let me go back to the slide and make it more clear that it's not. Sorry, let me go back here. So the shell and the UI are obviously sort of different processes, right? But everything else except the shell and the UI is basically all the parts that live in the admin jar, right? The admin process. This is just showing how it's sort of broken down a little more functionally. So the arrows really up there are like incoming traffic arrows, right? Okay. Should probably kill this guy. So we're not going to use it anymore. These are all dead. That's good. All right. So actually, let me show very briefly. Not. Oops. No, that's the one that doesn't have the. So if I look at I'm going to do time log, like a quintessential demo app. So there's stuff to go through here, but this is really what modules look like. They're using a new annotation enable binding. This is what creates behind the scenes all the channel adapters. This is how we handle the properties for the class. So time source, has a format in this case, how you'd like to print the time. And now you are encouraged basically to use Spring integration annotations to reference. We provide you some source, processor, and sync classes, but you can even have other classes that you have multiple input channels or multiple output channels per module. So that's another nice consequence of this approach is you have a little more flexibility there. So basically, this is a complete Spring integration annotation here with the triggering, and then we're just returning a new date format. So that's what the source looks like, the log sync.
Can you show us the imports to see what's specific to?
Yeah, sure. I mean, oops, I think there's some that are, looks like I could optimize the imports here. Right. Yeah. So, I didn't want to go into it in so much detail because Mark and Dave will really get into the programming model quite extensively, so it's kind of a pointer really to go more to that session to see what the programming model is for creating this. So things that are in Spring Framework Cloud Stream, this is what basically gives you the auto config. This defines that I'm going to have an output channel, and this is simply because we wanted to have better support for doing scheduling. Simplify just having a default scheduling. Let me just kill this. I don't know why it doesn't have a minimize button. So yeah. Right, so that's the default binding is Redis. So if I run this jar that's sitting there, and the important part here is that there's a property, it's a standard boot property, parsed by boot. Spring Cloud Stream Bindings output, and I give it a name. This is the shared channel. So if I go to somewhere I have Redis running. You can see, well, maybe not. There you go. I'll move it up. See, it's printing out the time every second, so it's going through Redis. So this app is just basically setting a time to Redis. Okay? I'll stop the CLI. And then, so this was a boot app. And if I CD to the other spot, the only difference here is I'm setting the input binding to the same shared name. That's the queue name, logical queue name that's in Redis. And I'm changing the port because the default port for all boot apps is the same, so I need to change to something different. So this guy runs, and there, maybe I'll make it a little wider. There we go. It's scrolling the time. So just two apps, very little code, and they're communicating over. Now these same apps are what we can deploy to a much larger, distributed setup. So one thing that Lattice supports is deploying to Amazon. So let's refresh here. So there's 4 servers here. One called Lattice Brain, as the name implies. That's the heart of the whole distributed system. Yeah, there's a question in the back.
Yeah, in that example, what's the transport that?
Redis is the transport, is the default. And we support Kafka and Rabbit as well. So you can change by changing the binding property to use something different. But the default is Redis. So the Lattice Brain, that's the component that is keeping track of where everything is, right? And has the components that decide where an app should be deployed. The places that it gets deployed are in these so-called cells. So when we do time log, one of them is going to be on cell 1, one of them is going to be on cell 2. And we're going to take the admin console, the new Spring Dataflow admin console, and point it to the admin that's running here. So if I show you, make sure. Oh, let me first show you this. Basically, did this, of course, before, because sending stuff up by Amazon takes, 5 minutes, 10 minutes. So basically, let's see how far up there we go. Yeah, so Terraform apply. After you set up all your credentials and whatnot, the Terraform script goes off, sets that runtime up, and gives you this target, basically. And so this is how you talk to that cluster. So you can go to, where is it? LTC is the Lattice command line. And I've already deployed 2 things there to speed up the demo process. Basically, I've deployed Redis. So Redis is running inside one of these cells. And I've also deployed the admin server. And so if I look at, I can do LTC logs, admin. That's another command to show the logs. Or maybe nothing is going on now. Let me do that after I deploy. Yeah, so here, actually, I already had it running the log, LTC logs command. So it's up and running here. Oops. So you see Spring Cloud Dataflow. This is the admin. So you get that banner, and then you get the boot banner as well. This was obviously from before, because I have it running. You can do LTC status. Let's see. Redis. So it's saying it's running on cell 0. In this case, it downloaded the Docker image directly. And our admin is also a Docker image. So it pulls down the Docker image and starts up and runs the admin. Oops. Yep. So let me go, I don't know, go here, yes? Go here. I start up the new. So I have to point it now to the admin server that's running on Amazon. All right. So there are no streams. So now we take our friend TikTok and redeploy it. And you see here, hopefully, list is, wow, so it started up already. So we have an app called TikTok log. And if I do LTC TikTok log, this is the log. So it's in the process of starting the application. This one is the time source. It's also starting up. All right, so it started. And there are the ticks going through. And all of this is running on AWS. Okay. So that's all I have. I think I finished, I don't know, 20 minutes early. Let me bring up the page here. This is the project page for Spring Cloud Stream, which is sort of the lower level project. Again, this is the one you could think of as boot for Spring integration and Spring Batch. We made a milestone release, so there are artifacts with the M1 tag. There is a similar project here. And you can go to the reference docs and show you how to get started locally on Lattice, on Cloud Foundry, and on Yarn. And then, more about the programming model, and then a little bit about some of the out-of-the-box modules we provide. So that's it. Really welcome you guys' feedback, and thanks for coming.